My name is Philipp. My background is physics, actually. I did a PhD in particle physics back in the days in Hamburg, Germany. We had one of these nice accelerators. There you can see the experiment. So it's long ago, but we already had some kind of big data at the time and neural networks and that fun, fancy stuff. Yeah, since 15 plus years, I've been a freelance data scientist, data engineer. Slide is a bit messed up, but okay. So I've co-founded Keystone a year and a half ago. It's an AI studio where we build bespoke solutions for mainly small, medium-sized businesses. And I'm also co-founder of a meetup group called Embrace AI. So yeah, if you're curious about that, please look it up. We have an event on Thursday. Come join us. Because I think it's always better to have a tangible example when you try to explain concepts. I'm doing this. It's based on a project that I did for a client, but since I can't show any proprietary data and so on, I did an example which is similar, but based on public data. So it's about a tax advisor, AI and human, and about VAT tax. We'll come to that in a second. And based on this example, I'll explain the different topics relevant to my talk. So I'll give you an introduction, give you an anatomy of the determination, how you determine VAT in order to build a solution that can automatically do that, and then go more into the details of search problem that I'm going to discuss. Okay, I need to remember which way to go. So the tax advisor, side by side, the human tax advisor, right? Like, how does he work? I imagine the tax advisor, he studies the laws, like the EU law, then the laws from all the countries. He studies all the administrative decrees and so on. So he has all this knowledge in his mind. He knows it by heart. And then he can derive like all necessary information for a certain case, how to determine the VAT, right? Now, we could in principle do the same with an AI, right? And that's what's been done, right? The models are being trained and all that knowledge is put into the models, but yeah, we don't want to rely on the inherent memories of the models, right? Because we all know they hallucinate. And also, it's not a good idea when you get audited to say, yeah, these numbers are because Claude told me. That's not a good idea. So you want to have ability. So whenever the AI or the automated system decides on tax rate and who's being taxed and so on and so forth, you want to have the exact trace of decisions and laws it's based on. And yeah, we can use agents now these days. Agents have become very strong in solving all kinds of problems. And this is what I'll demonstrate now. So let me first explain a little bit based on a very simple case, like how this VAT determination works. The questions that you have to answer is, does VAT apply at all? What kind of transaction is it? Where is the place of supply? Is it taxable? What rate? And so on and so on. So these questions you have to answer. And on the left-hand side, it's an actual example. So it's a made-up example, right? Of course, but still. So you have Lusobuild, a builder from Portugal. They're building homes and they need cement, right? So they buy cement for 200,000 euros from a seller called Cementos do Norte. And they actually deliver the cement and they get invoiced. And they pay the amount plus the tax, which is 246,000 euros. But now, Cementos do Norte is a fraud. And they don't actually exist as a business. And so they don't actually pay the tax to the authority or to the state of Portugal. And so the tax authorities say, look, if we haven't gotten the money, you're not allowed to deduct the tax on your side to the Lusobuild, right? And Lusobuild says, yeah, but it's not our fault. They're a fraud and we didn't know. So we want to deduct. And this is a case where this is not reflected by the law, right? So you can't look it up in the text of the law. Instead, you can go to a court and the court rules. But of course, you can look up precedents, right? And a case like this most likely has happened in the past. So there is a ruling which already exists. Okay, so let's look a little bit closer to how our agent can go through these chains of rules in order to determine who has to pay the VAT, where to declare it, and so on and so forth. It's all based on some basic rules. It's particularly the VAT is very rule-based. So you have a directive of the European Union There you have all the rules that reflect what I've discussed 2 slides away. And then you have the laws which are in place in all the countries, for example, Portugal. Rules, very deterministic, auditable. And in order to get this information, we don't need any retrieval. Or this is best solved by just a skill, right? You define a skill and you say, look, the first step is to apply these rules. And this is the first thing you do. Great. The second thing is, if you come to a conclusion, we want it to be auditable. So here's a bunch of files. Right? We had this Obsidian case, for example. So you can do it with Markdown. This is the laws of Portugal. Just find me the laws that your decision is based on in order for me to really be sure this is derived in the right case. And for this, you would use grep, for example. This is what all the harnesses use, right? You have the files, you can go through the files. You have exact wording. The agent already knows what it's looking for. Great. No semantic search needed here. And also for number 4, for example, if you want to derive the text rate, in Portugal, the full rate would be 23%. For stuff like that, you also look up a database or a file, right? So you can give it a tool. Now, number 3, and the 4th layer there, where we can use neural retrieval, where it's not very well defined what to look for and so on. And that's a specific case. So I'll talk about this where neural search pays off. And this is in cases where you do a discovery, I would call it. It's not verification. We don't know exactly what we're looking for. We have a problem, but we don't know if the information that solves this problem even exists, right? And that's what we call discovery. And this is, if you, in case law, if you look up laws that are precedents, for example, but also if you're a researcher or, you come up with your case, there's a lot of discovery cases out there. And this cannot very well be solved by a similarity search, but needs to be solved by relevancy, which is defined slightly differently than similarity, right? So we come to that in a second. It's not similar, but it's somehow associated with my problem at hand. So based on my problem, I ask a question to the system and hopefully get a meaningful answer, right? And in our VAT law case, I'm sorry, the slides are messed up. Something went wrong when transforming this to PDF. But okay, we have to deal with this. I'm showing you this. This is an actual result of a ruling by the Court of Justice of the EU of the case that corresponds to the question that we had. What happens if the seller is actually a fraud? And there's no bold text. So I marked a couple of words that is relevant in order to answer this question, what's now happening. And it's essentially, did the buyer know or act in good faith, right? That's a differentiation here now. So this is the information that you're looking for, and it's nothing to do with cement or building or whatever. It's discretion. Okay, now moving towards an actual solution to this problem, the question where it goes agentic. So this is an idea that has come up just a couple of months ago, and I really get a bit excited about this. I think it's a very nice and interesting concept by this research group from the University of Waterloo, and they call this reasoning-aware retrieval. And they actually came up with this in the context of BrowseComp. I don't know if you guys have heard of this. It's a benchmark in a data set that contains sources from the internet. And you have a question that cannot be answered by a single chunk of data that you find in that data set, but it's a multi-hop thing. So you look something up, you find a hint of what to look up next, and so on. And you have to find 3 documents or so in order to actually answer the question. And what they came up with is they don't only provide the query. That's what I'm indicating here. What we usually do, we have one input, do a similarity search, for example, and get an answer back. But they combine that with reasoning because they thought, okay, the entity that is searching is not a human anymore. It's an agent. So agents are not lazy, and they can write out what they're thinking. And from this reasoning process, it's actually a strong signal of where to look in the data. And that's what they did. So not only the query goes in, but also the entire reasoning what it is looking for. And that's the idea of agentic retrieval. Now let's have a quick look on how to technically solve this. And I want to discuss some different technologies that we're using in order to retrieve information, right? And most of them or all of them. It starts with the BM25. Who does not know what BM25 is? It's lexical search. Yeah, it's just a keyword search. And grep, you're also very aware of. Grep is actually very powerful, right? It's not, when I use grep, I have 5 expressions or so that I use, right? But AI agents, so they can really formulate very sophisticated grep statements or whatever. So grep BM24, it's cheap, and you find stuff that actually matches exactly, right? Pattern matching or yeah. And then you have dense single vector. That's a very popular solution for semantic search, where you turn your text into one representative vector for the query and for the document. And then you compare these two. And the ones that are similar are supposed to be relevant for the research, for the result. So this is what most people know and use. And if you want to further improve the quality of your results, you use a re-ranker. I'm also pretty sure most of you know what that is, right? So the re-ranker, the important thing is that it takes the query and the document at the same time and evaluates both. It's like before it was independently and only the projection, so to say, was compared. And that's what makes it strong. And also you can train re-ranker in order to have the best possible result on your data set, right? It's slow and also depends on your use case. It's of the order of 500 milliseconds you need. The small ones still run on CPUs. You can use GPUs, so it gets more expensive regarding the hardware. Next idea here that I listed is the list-wise re-ranker. The idea is actually very simple. For the point-wise re-ranker, you rank each document separately and then compare the scores and have your result list. And list-wise means that you put in all your document candidates. Say you have pre-filtered your documents and you're left with 50 documents or 100 documents. So all of these together with your query go into an LLM, say, and you ask the LLM to rank the results by relevancy. That's essentially the list-wise re-ranker. So it's gorgeous, but it's slow, of course. It's a request to a full-size LLM, right? And then we have the late interaction, and that is a mixture, I would say. And again, we have the query and the document that go into a neural net. But instead of doing the pooling and being left with just a single vector, what we had with the dense vectors, you keep one vector per token, right? So if you have a document with 300 tokens, you end up with 300 vectors. The vectors itself, they're a bit smaller, but still the size of your index is much bigger than of your dense retriever, right? You do the same for the query. So this you can do offline, right? So you only store you store the token vectors for your documents that you look up. Then you do a query, you generate these, and then you compare them one by one. So for each token vector in the query, you look up all the token vectors in the document, find the one that matches best, store them, and then you sum them up in the end, right? And then you get a result for each document. And the one with the highest sum, obviously, is the one which is best fitting your query. So yeah, that's very neat. It looks expensive compute-wise, but since you can do this offline and you can prepare this in a database, the retrieval is actually very fast because you don't have to do that for all. You can do a pre-filter and then you can, it actually scales. So you can have a retrieval in less than 10 milliseconds, I would say. And the quality is really comparable to what we get with the re-rankers. And even, I would argue, with the list-wise re-rankers, so with the full-sized LLMs, if you train it to your case, right? So if you consider your data and your pattern, so to say, so the question answer. Okay. So yeah, I'll go a little bit into the training pipeline. This is the pipeline, roughly, right? First step, get your data straight, understand what your data is, and have it clean. Then, and this is just my learnings, what I would do, get a baseline, right? Run BM25, run single vector. You can use a smaller one, use one from OpenAI, whatever. Use off-the-shelf multi-vector, so late interaction model, what I've described, and see how it performs, right? Is it good enough? Great, you're done. If not, then yeah, we do the training. I'll go into that in a little bit of more detail. So the data, again, we have our example. This is 2 snippets of the data for this particular data set of the rulings of the Court of Justice of the EU, looks right. This is actually an artificial query plus reasoning. I can explain that. So from these cases, each case comes with a dedicated case. And that's actually what I was using for this demonstration for the evaluation. But the data set is pretty small. So, so I synthetically created other cases which are similar, but different in wordings, right? So I trained it with the synthetic data and tested against the actual data that I had. And yeah, make sure all your snippets are clean. So you have query reasoning and then an answer that is actually corresponding to what you want, right? Okay. It's a bit shifted. Anyways, yeah, what I've just explained, right? Start, if you can, if you have data, if you have real data, that's the best, right? If you don't, if you have a little bit of data, try to use that for the evaluation and try to use synthetic data to train your model if necessary. Okay, and then generate the query and answer pairs. And yeah, this is actually a nice method that I've been using. So you pull from cheaper pre-filters. So BM25, a small dense retriever, but it's important you have different retrievers in it to have this variety of results. And then based on that pre-selection, you can use the list-wise re-ranking. You just put it all into an LLM and you get your preferred answer, the golden answer. And also, very important, you get negatives. It depends on the data set, how important the negatives are. But this gives you actually results that look similar, that you would retrieve with a BM25, for example, but which is not relevant, right? So when you take the ones from the bottom here, and so you would use these as negatives for your training process, right? And yeah, I think another point that I want to make is list-wise re-ranking has really become affordable because even the smaller models, I think, became very powerful in differentiating between valuable information and less valuable information, right? So for this demo, I used the DeepSeek Flash, super cheap to use. And I compared the results with what Claude gave me and the DeepSeek Pro, and it was fine. It was mainly the same results. So I think this has now become affordable. Of course, if you don't want to send your data to China, you have to spend a bit more. For this demo, it was fine. Okay, I'll not go into the details here, but yeah, I used one of the models that is famous for this late interaction. It's also called Colbert. There have been a couple of models which a lot of people use. This is one of them, the modern Colbert from a company from France, Lydon. And yeah, this is already performing pretty well. It's comparably small, so only 149 million parameters, which makes it really handy to fine tune. So actually, I gave you this number for this demo, and for reasons the data set was pretty small and the results were already pretty close to the optimum. So the fine tuning didn't have an effect in this case. But usually, if you want to do fine tuning because your results aren't looking perfect, you can actually fine tune this 149 million parameter model for $1, right? It's really affordable. And then you have a state-of-the-art retriever with this Colbert model. So Time's up. Let me conclude. So the lessons learned, look at your problem and decide which retrieval is deterministic and which isn't, right? So when you have rules, when you have laws, and when you already know what to do or can tell the agent what to do, you don't need semantic search, right? You only would use that for discovery. And yeah, for cases where you don't want similarity but relevancy, right? Also, the agent, I'd say, is the new kid on the block for search. It's okay. Everybody knows that. No one is Googling stuff anymore, right? Because it's tedious. You need to look through several pages, conclude, and so on and so forth. No, we ask Claude or ChatGPT. They do it for us. And I think, yeah, that's the current pattern, and that's where we're heading. So the agent is looking up stuff and giving us the best possible answer. I found that LLMs really give human-like performance, I would say, in the ranking of results. If you use frontier models, it's hard to argue with them. My recommendation, when you do neural retrieval, use latent action. It comes with a lot of benefits. And yeah, only get your baseline. And if that's not good enough, then you can fine-tune it again for cheap, right? And yeah, in order to get a good training set, use this mechanism of pooling together the results of different base retrievers, and then do the list-wise re-ranking and use that for the fine-tuning for the training. Okay. If you say that's all good and nice, but I don't want to have anything to do with retrieval, I want to take care of my business, feel free to reach out to me. Also, if you want to hang out with other nerds like me, your peers, and yeah, have a good time, join the Embrace AI meetup this Thursday. It's the next meetup. Thank you.